So we'll start the lecture 6. From now on, we are going to learn descriptive geometry principles. So those are projection methods, point, straight line, and a plane representation using orthographic projection method. Okay, so as another way of description of this as Monge projection method. Okay, so Monge, Gaspard Monge is inventor of this method. So that's why whether Monge, it calls Monge projection method or orthographic projection method. Okay, so it has several parts. So this is part 1. Okay, so what a descriptive geometry is? Let's see the description. Okay, so descriptive geometry is a branch of geometry which uses a specific set of procedure to these 3 things. Okay, so these 3 things are included into the geometry. So the branch of the geometry is a kind of the branch of the geometry which is learns and which study these 3 things. Okay, so the first one is represent 3-dimensional objects in 2-dimensional plane. So we are using 2-dimensional plane for representation of 3-dimensional objects. Okay, so in the reality we have we might have some kind of 3D shape like a cube kind of thing in 3D. So for example, but this is in this 3D, but we are using this 3D to represent in the 2-dimensional. So for example, we will divide an axis. Okay, so that is so 3 axes, but in here say that is x axis, that is y axis, that is z axis, right? So in the 3D, that is in the 3D space. So in reality, but in the paper, paper is a 2-dimensional space. Okay, so that's a 2-dimensional space. So that's why we can make like this. So x is this one, and y is this one, this axis, and z is that one. Okay, so x, z, and y. So we're drawing on the plane. So how to draw this on the plane? So here the square shape. From the top plane, we can see the again a square, and then from the left-hand side, we can see again a square. So if you have this kind of 3 squares drawn, and if there are 3 axes there, okay, so x, y, z, so that means that's a cube. Okay, so in this 3D, so we are representing 3-dimensional shapes in the 2-dimensional. Okay, so in the 2-dimensional space. So if you do this one, that means that is like descriptive geometry study this. Okay, so descriptive is included into the descriptive geometry. So that's the principle of descriptive geometry. Okay, so the methodology, and that calls orthographic projection of 3-dimensional thing into the 2-dimensional space. Okay, so that is orthographic projection. That's called orthographic projections. Another things we study in descriptive geometry is solve spatial 3D problems using plane constructive methods. Okay, so when we use the planes, so planes in order to solve the 3D problems, that is a descriptive geometry. Okay, and the third one is reconstruct a 3D object from its plane image. Okay, so if you have 2-dimensional planes, 2-dimensional shapes, if you create 3D by using 2-dimensional things, that is also the task of descriptive geometry. Okay, so 3 things are included into the descriptive geometry. The first one is from the 3D to represent 3D thing into the 2-dimensional plane or space, or solve 3D problems is using a planes. Okay, plane method. And the third one is reconstruct. Okay, so make a 3D thing using 2D. Okay, so that is as three things are included into the descriptive geometry. Another thing is there is a set theory. It's kind of a branch of geometry. So in the set theory, all geometric figures should be constructed as a set of points. Okay, so set of points, lines. Okay, so those many points. Okay, so it's any line can be constructed from many points. Okay, set of points. So many thousand points. So the branch of this science about that kind of set of points that calls set theory. Okay, so for example, the house is given in the reality like in a 3D. So to generate this one, we use a two. Okay, if you want to make a drawing of it, so you are mapping it. Okay, so you are projecting it from one side. So on the page you can have lines, but if you see using microscope that or if you imagine that lines are constructed from many points, it might be constructed from many thousands of points. So we used kind of set theory also. Okay, so mapping of geometric figure onto any plane or any surface could be fulfilled by projecting its points onto that plane. Okay, so how to do this? Okay, so every corner of the house, every features of the house, the corners points can be projected into the 2D, and then by using that two-dimensional, okay, and using that points, projected points, we can generate the lines and the features of the house. Okay, so in the two-dimensional page. So that is orthographic projection of a facade. Okay, so the house one side or the main side calls facade. So that facade's projection in the 2D it calls orthographic projection. Okay, so orthographic projection. So there is a projection methods. Okay, so two types of projection methods exist. The basics. Okay, so basic types. There are a lot of types, but mostly two types: the central projection and parallel projection. In the central projection, we are looking from one point. Okay, so from one point and looking to the building or to the object, to the car, to the any equipment. Okay, so and in reality, if you see by your own eye, okay, so by using your eyes, that is a central projection. Okay, so because you are looking from one point to the big building from your point, from eye point, from your eye location point. It's a one point, and you are looking to the every side of the building, even though that building might be very big. So that's why that's a central projection. Okay, so we are looking from one point. And the parallel projection is like we are looking, if the object is like this, so a cube. So we are looking from using parallel lines. Okay, so parallel rays. So and so that's why the sizes are not changing by this side. Okay, so if you see, so how you look it, if you see like this way, so the way to the arrow. Okay, so you will see something like this thing. So sides or edges of the cube will be a parallel also, because you are looking with parallel lines. So this line and that line will be a parallel. This line and that line are parallel, and that one also parallel to this one. Okay, but if you see with central projection, so you will see something like this. So this edge will be bigger, and that is the side edges will be smaller because it's far from us, because we are looking from one point. Okay, so you will see something like this view, something like this view. Instead of this, you will see this one. So this is a central projection, and that one is parallel projection. So orthographic projection also is a kind of is a type of the parallel projection. Okay, so we'll see later on in next slides. So central projection, let's see how it looks like a central projection. So here the P plane is given. Okay, so P plane is given, and points S and T points are given in the space. So in a 3D space, in real world space, is given point S and T. Okay, so and we are looking from S point to the T side, right? To the T side, we are looking like this way, and then this T point will be projected on the plane P. Okay, so the plane P and point S given in the space, such S is not at infinity. Okay, so and not lying in the plane P. Okay, so S is lying somewhere else than P. Okay, so outside of the P. So then the transformation that maps a point T is not equal to S to the point T dash, which is the intersection of the line ST and plane P, is called the central projection of the plane P from S. Okay, so T dash, how we generate T dash? So we are making a line, ray or line from S to T, and then we, if you continue this line, that will intersect the plane P, so then that will generate point T dash. Okay, so T dash means point T's projection in the plane P. Okay, from S side. So that is a central projection of T point into the plane P. Okay, central projection of point T in the plane P. Same thing with the same thing. So we said many objects can be generated by using a points, right? So if you project every point of the object into the plane, so you can generate the projection of that object on that plane, right? So that's why by using many points, we can project many points into the plane, and then we can generate the projection of that. Okay, the object, like triangle is given in the space. How to project it? So by using S, we can make lines from each edges. Okay, so each edges of the triangle, and we can. Okay, so that lines are intersect plane P. So that intersection points, if you join that intersection points, so you can generate this kind of gray color triangle. So that gray color triangle is a projection of this white color triangles on the plane P. Okay, so that's also central projection of a triangle. Okay, so plane P is called the projection plane. So this one is a projection plane, and or it might be called like a picture plane also, picture plane. So we are generating kind of picture of this object. Okay, so and S is called the center. Okay, so this one is a center, that called center because of center projection. So that is a center. So we are looking from this one. So your eye will be here, like if you look from eyes, and the lines ST. So this line, so ST line, so this line, that lines are called rays. Okay, so rays of central projection. So here are 3 rays: 1 ray, 2nd ray, and 3rd ray. And by using 3 rays, okay, so rays, we are generating a projection of triangle on the plane P. Okay, similar example. So S is central point, right? So from D side, okay, so from D side we are looking to the S, and so B and C is projected onto the plane P. And please note that on the space, points are labeled as a capital character. Okay. So points on the 3D space in the 3D space, in real space. So the points uses capital characters, so big character like S, B, and C, and the projections onto the plane. So in the plane, the projections, they're using small characters. Okay, so B, C, something like that. Even and another projection like from S, okay, from the center, the projection of the A is this one. So it's also small character. So 3 points are given on the plane P. So if you have small characters on the written, so that means that's the projection. If you have big characters, those are on the space. So another example, okay, so central point, projecting center, and point B is projected as a B dash to the P1. And to the another side, like A point, A1, A2 points are projecting as a A dash. So that A dash and B dash are projected points, and on the space, so B and A2, A1s are projecting points, and without dash, those are projecting points. P planes are projecting plane, and S points, central points, are projecting center or just a center. So here you can see different example. So point A and point B are given, but you can see 2 centers are given also. So S1 and S2. S1 and S2 are given. How to project it? So if you project A point with using S1 projecting center, so you will get A1 dash. So if you want to project with using S2 projecting center, so you can generate A2 dash. Similar for B. Okay, so the projection of the B is using S2, so you can generate B2 dash, and then with S1, B1 dash. So similar projection ways. Okay, so can be. That is a central projection. As we told you, many objects, the lines, surface, even though the objects can be projected by using a points, one by one points can be projected. Projected into the plane, so such a way. Okay, so central point is given, and this AB curve is given. Okay, so curve is given in the space. How we do? So we can make many points on the curve, and then by using rays, okay, so from S to that point, we can generate a ray until that will intersect the plane P. So then the point A or A1 can be generated here, and another plane, another point. So many points can be find that the intersection points of the projections, like as the projections on the P. And then if you connect them, that will be a projection of the curve onto the plane P. Okay, so similar like this. So C and D is given in the space, and the line is given on the space, and is using S center. We can have a line like this, rays, and then we can have this line. Okay, so we can generate a plane also. Okay, so by using 2 lines, a projection line and projecting line. Okay, so projecting line, projecting point, we can generate a plane also. So soon later we'll see those things, how to use this. Okay. So the second way of projection is parallel projection. As we told you that parallel projection the ray, okay, the projecting ray or projecting side is parallel with a projecting center. Okay, so for example, point T is given, and ray S, the line S is given, and so we will generate a parallel line to this ray. So then that ray intersects the plane P. So then we can generate the point T dash. So point T dash is a parallel projection of the point T to the S ray side. Okay. So similar to the previous example, the triangle can be projected with using a single ray, and then all are parallel, you see, and the projection is a parallel projection. Okay. So that is a orthogonal project. If the rays are projection are orthogonal to the projection plane, that means the ray angle to this plane P is very important. So here you can see that angle is less than 90 degree. So if you do this S as a perpendicular to the plane P, it's like a 90 degree. So that will be a orthogonal projection. Okay, so if the rays or projection are orthogonal to the projection plane, then the projection is called the orthogonal projection. So if you have any question, please ask. So two guys are want to ask something. Okay. Okay. So I can. How we define where is S? So S is given. Okay. So S is given. Like this is just introduction. So I will show you how to define and how to draw. Okay. So this is kind of if the note is S is given, right? And the point T or any point in the space is given also. So we are looking from S to the T side, and we can make a line, and line intersects the plane P. Plane P is also given. So then we can find a projection point on the plane P. Okay, so
Okay.
let's continue. Let's continue. So this is a parallel projection. So here point B is given, and AS line is given, or ray is given. So projection B dash on the P1, the parallel projection. So or many points are given in the space, and to the and S some ray is given also. So all those things are equal to the A dash. Okay. So because all this lies in one ray, in one line, and here two rays are given, and S1 ray and A and B points. Okay, so A and B can be generated to the parallel projection S1, like A1 dash and B1 dash. And if you use a ray S2, that will generate B2 dash and A2 dashes. So this is a orthogonal projection. If the rays, okay, so this S, S2, S1 are perpendicular, orthogonal means perpendicular, okay, so perpendicular to the P, to the plane P, so that will be orthogonal projection. We are looking from the front of the object, okay, so front face of the object. So that is a perpendicular projection or orthogonal projection. So T point in the space and T dash in the P. Or triangle shape is given like this, but we are looking perpendicularly to the plane P, and then we are projecting, we're using parallel lines to each other and generate these red dots and generate this triangle. So there was a question which channel you post the lesson to. So I will post this recording to the drawing material channel. Okay, so from your own group you can find your materials. So let me show. The channel. So in the chat, I uploaded, written. You can see the links to the channel. Okay, so from that channel you can find this recording. So orthogonal projection. Orthogonal projection or orthographic projection, also similar thing. So please note that the points, how they could describe, like how the points are defined. So here X point is given in the space. So in the picture plane, that can be defined as like, or labeled as XP. Okay, so point X, and that is XP because the plane P. And in the sheet, in the paper, you can write like X, just small x, or X dash, or X2 dash. Okay, so it's depending on the on which plane is this. Okay, but normally we use small character of X. Okay, and okay, what's a Monge method? Orthogonal projection. What's the orthographic projection or orthogonal projection? Is using Gaspard-Monge method. So the Monge is lived in 17th, 18th century. Okay, so at that time there was no 3D, no computer, no software. Okay, so that's why. But the problem were similar problems. Okay, so there was a problem. There were a problem of 3D, like with using 3D, they without using 3D, they need to, at that time they need to build some equipment, some kind of ships. Okay, so but the difficult problem without using a 3D. Well, how they did this on that case? So they did kind of projection method. So for example, point T is given in the space. So they use a page, two-dimensional space in order to represent this 3D space point. For example, the point T is given here, and then there is a distance. Okay, so this distance is important, and that distance also important. So they give these two distances on the page. Okay, so they did this line. Okay, so here they wrote they draw a line, and then on top of the line there is a 1 point, and on the bottom of the line there is a 1 point. So that means given 2 points represents only 1 point in the space. Okay, so this distance is this distance. Okay, so distance, upper distance, say upper, this is upper distance, and this lower distance L, so that is a okay, sorry, so this one is a actually lower distance. that's lower distance, and that is upper distance. Okay, so they open so this was the previous was correct. So that is a lower distance, this one, and that is the upper distance. Okay, so that's the upper one, upper distance, and that is a lower distance. So they open this the plane to the dawn, and then this is like this side. Okay, they open this, and then they generate the point T dash and T double dash. Okay, so if you have this kind of line, and then 2 points are given, and in between the line or there are no line, it might be also, and the notation can be given like T small character, T dash, 1 dash, and just T. That means only 1 point is given. Okay, so do not say this is 2 points and okay, so let's continue the lesson. So the point T on this in the space can be generated with using just normal page. Okay, just 2-dimensional space like this way. So by opening this horizontal plane to make a horizontal plane as a with same frontal plane. Okay, so 2 planes can be shown in one plane, but this corner, the corner which is intersection of a corner of 2 planes can be drawn like this way. Okay, so just a line, and then a point on the top and point on the down. In between a line, it might be dash line or just normal thin continuous line that represents a point. So he did, the Bunch did this thing in these years. Okay, so he actually he used this 2 planes to intersect 2 planes with using 2 planes the 3D shape. Okay, so 3D space he cut with using 2 planes, so plane 1 and plane 2, and then so that intersect the 3D space into the 4 quadrants or 4 quarters. Okay, so quarters, divide the space into 4 equal pieces. So, and then by changing these planes, so he represent on the page or just normal 2-dimensional space, he used the shapes in 3-dimensional shapes in the 2-dimensional space. Okay, so he generate this kind of method. Okay, so drawings with 2 projections. So, but what we need just for 1 point, we need to show 2 spaces, right? With 2 planes, like we have to show. Okay, so 1 point will be 2 point or 3 point. 1 line can be in the space, 1 line in the 2D, it will be 2 lines or 3 lines, so something like that. Okay, so here the center O, and x-axis is this one. Okay, so let's draw. So this is a space. Okay, so this is Z side, that's X side, and this is Y side. That is center. And the Y side, we have 2 Y sides, because if you have a box, like say we have a box, say like a cube shape. So 3D space, our world is consists like this space, right? So 3D, so similar to the box kind of thing. So we have 3 dimensions in the geometry point of view. Okay, so so 3 dimensions, like say this one is, that's X, and that is O, and this is Z, and that is y-axis. And if you cut here, so say, just imagine this is a box, okay, so paper box. So when you cut one side, you can open that box like this way. So that is one side. That's another side, the bottom side, and that is another side. So then we can say that is x side, that is z side, okay, z axis, and then that's y side. So because of this one is we divide by cutting, okay, so we cut one edge, so that's why this y and that y are equal, okay, so this y and that y is equal. So same this one, same to this picture, same like this picture. So that's why here y and this y are equal. So when you draw anything here, and if you measure this distance, and here also will be same distance, okay, so because that's the same thing. So that's why when you draw something, you can measure and make a same drawing like this, and then you can intersect and generate the third one. If you have two-dimensional shape, okay, or two projections, so third projection you can generate by using these two projection, okay, so projection, front view projection and top view projection is given. So the right or left hand side view projection can be generated by using front and top, okay, so by using two projections, projection 1, 2, 3. So 3 can be generated by using 1 and 2, okay, so why? Because of this, okay, so the distance of this one same to this. So the distance of the height can be generated by using z's, right? Okay, so here the shape. So every points, okay, you can generate many points are here, and then you can measure the height of this, every point height from this front view corner or front view side, first plane. From the first plane, you can measure every height of the points, and then from the top side, you can generate that point of up to plane 1. Okay, so anything. So and that things can be inserted here, and also the distance of the points of this, the x points, x values can be taken from here, and then you can make like this intersection. You can generate from this side, okay, so from this side you can generate the third view by using 1 and 2 views, okay, so 1 and second view can generate the third view. So by using this orthogonal projection method, okay, so let's see other things like how the point can be defined, how the point can be given in an orthogonal projection. Okay, so with using three planes and with using three projected points, how point A can be given. So like this way, like let's say I have a okay, so point A is given. Okay, so the big capital character here, you can see the green point is given. So this point, okay, so this point is given with capital A, and that is on the space, okay, so in real life. So how can we can draw this one in the two-dimensional paper, two-dimensional space? So we have to make like this two lines, okay, so and we project to this side, V side, okay, so V is profile view, frontal view, front view, okay, so front view. On the front view plane, we put that point, okay, projection. So and then we wrote there with small character and with dash. And how about on the horizontal plane? So just we measure the height of the point, and then put same this okay, same this distance. Okay, so distance x is taken from A, and then put point A, just small capital character A without any dash. So that plane calls horizontal plane. So H. And in the third plane, that is W plane, that is profile plane. So we measure. So let's make a straight line. We measure this distance. Okay, so that distance, and then just make a same distance. Okay, so you can make a 45-degree angle, or you can use a compass. So make this same size. Okay, so then make straight line again, and then you can use this level A. Okay, so that distance are equal to this distance. So then we can define a point A2 dash. So the intersection point give you the A2 dash. So that is the space, the plane W plane. So that this W plane, that's the profile plane. So V plane, let's repeat. Okay, so V plane is a front plane, frontal or front. And the beige color one is H plane is horizontal or top plane. Another way is top plane. That's a front plane. And W is profile plane. Okay, so plane XOZ is a frontal or front plane, and XOY is horizontal plane or top plane, and YOZ is profile plane. Okay, so and we have to use the lines also, because thin lines, not thick one. Okay, so thin lines, thin narrow lines. So point A. So by using these 3 point and these lines, A point is given. Only single point is given. Okay, so if you see here, A small a small a dash, small A2 dash, those 3 points means 1 point is given in the space. Okay, so don't say 3 points are given. Okay, only 1 point is given. Okay, don't say 3 points are given. No, only 1 point is given in the space. Okay, but we use a 2-dimensional page. So how it looks like. So here 3 planes are given. The yellow one is top plane, and blue one is front plane. Okay, and the purple one is right plane. Okay, so and point A is given. So this red point is given in the space. So you see in the space, not it lies. It doesn't lie on a plane, in any plane. Okay, so it's in the space. So we will project it. We will project it as a orthographic projection. It's a 90-degree projection to the plane, front plane. Okay, so that is V plane, and we will generate this point. Okay, so point A dash point, the green one. Okay, and then if we project to the yellow top plane side as an orthographic projection, we will generate point A, okay, small a, without any dash. And to the purple plane side, that is a profile plane or right plane, we'll generate A2 dash. Okay, so A2 dash points. So it's kind of this kind of projection. So if you open to the 3 sides, so we can see 3 plane, like front plane and top plane and right plane, and only 1 point is given here. Okay, so 1 point's projection, point A and point A dash and point 2 dash. Okay, so so 3D space is given. Any object can be generated in this space and then can be projected into the 3 plane, and then by giving or by drawing this 3 plane in one page can be given the sizes of any object, okay, in reality, without having 3D. So